Hello guys, today's Leetcode problem will be K inverse pair array. So let's see the question. So for an integer array num, an inverse pair is a pair of integer ij where j I and j will be between 0 to that array's length, and the value of that particular index I should be greater than the value of the element at index j. Given two integer n and k, return the number of different array consists of numbers from 1 to n such that they are exactly k inverse pair. Since the answer can be huge, return it modulo 10 power 9 plus 7. So the question states that we will be given an n and k where n represents an array from 1 to n, where k represents the number of inverse pair. So we need to return the array which contains the exact number of inverse pair. For example, let the n be 3 and k be 0. We will be having an array from 1 to 3. So the inverse pair should be 0. That means the array should be in an increasing order. So let's say in another example when n is equal to 3 and k is equal to 1. So here it mentions that we can have exactly one inverse pair. So and the array size will be 3 and the element will be from 1 to 3. So array can be 1, 3, 2. So this 3 and 2 is an inverse pair because 3 is greater than 2, and 2, 1, 3 is also an inverse pair because 2 is greater than 3. So we have two array which contains exactly one inverse pair. So I recommend you to pause this video and try to get a logic of your own. So next part we will be looking into the logic. The logic is, let's see an intuition behind this. So let's take an array 1, 2, 3 and 4. So shift any element a of I x times, then it generates x pair of inversion. So let the element be 4. If we shift x times, so if we shift 2 times, that is 1, 4, 2 and 3. So the inversion pair that we get will be 2. So let's take another example 2, 1, 3 and 4. So let us consider this as an array. So the number of inversion pair we got is 1. So let's try to shift the 4 leftwise. So which will be 2, 4, 1 and 3. So the total number of inversion pair that we get will be the previous thing plus the number of shift that we make from the 4, that is 1 and 2. So total we will get 3 shifts. So the total number of inverse pair will be number of shift on 2 and 4 added. Number of shift of 2 and 4 added. Let's see an example like 1, 2, 3 and 4. When we compare these two array, the number of shift that 2 has is 1. That is, we are shifting the 2 here and putting the 1 here. So it will become 2, 1, 3, 4. And number of shift the 4 we are giving is 2. That is 1 and 2. So the 4 will be coming here. So the total number of inversion is 2 and 1, 4, 1 and 4, 3. So total we are getting 3. That is 1 plus 2. We are getting 3 inversion. So this is our intuition. After we saw the intuition, we will be seeing how to add a new n to the n minus terms already generated. Let's say we are having an array from a1, a2 till a of n minus 1. We need to add a of n to it. Then a of n will create an inversion with the inserted position to the position n. So what it is saying that if we have an array which contains n minus 1 element and the number of inversion pair as k minus I, we will be inserting a new element at ith position to get exactly k inversion pairs. So for an example, let's say n is equal to 5. and we are getting n minus 1, we are taking n minus 1 array as 1, 2, 4 and 3, and the inversion pair we need is total inversion pair we need is 4. So we need to add the new element 5, but in which position we need to add, think about it. So here the total inversion count will be 1, so remaining inversion count we have is 3, remaining k we have is 3. So we need to place the 5 in such a position that the total inversion will be 4. So we have 1 and we need the remaining inversion as 3. So what we will be doing is, instead of placing the 5 here, we will be making a left shift of 3 positions. That will be 1, 5, 2, 4 and 3. So now we will be getting total inversion as 4, inversion pair as 4. So let's extend this idea further. Suppose we know the number of arrangement of an array with n minus 1 element, with the number of inversion pairs as from 0 to 0, 1 till k. Let's say being count to count 0, count 1 till count k. So each inversion pair contains number of count. This count contains the permutation of arrangement of an array till count k. Now we can determine the number of arrangement of an array with n element with exactly k inverse pair easily. To generate the arrangement with exactly k inverse pair and n element, we can add the new element n to the arrangement with k inverse pair at the last position. So if we have the k as value 1, we can place the element at k minus 1 to get the total number of inverse pair as k. For example, for the permutation with k minus 1 inverse pair, so if we have a permutation with k minus 1 inverse pair with n minus 1 elements, we can place the position of element n at left shift of position 1. Similarly, for element with k minus I, similarly if we have n minus 1 element and k minus I inversion pair, we can add this new number at the position of ith step from the right. So we can add the element n at the position of ith step from the right, that is left shift position. This insertion update to the array leads to new permutation with the number of inversion pair being equal to k. The base condition is when n is 0, that is when the array size is 0, the arrangement we will get will be 0. When the k is 0, that is when an inversion is 0, the total number of arrangement we will be getting 1. If inversion is 0, it is simply an array of increasing order. If inversion is greater than 0, the array might not be in increasing order, it can be in random way. And the next point is we should be considering the concept known as the limit. So here, if we have an array of n, the total maximum number of inversion that we can get is n minus 1. That is, for n is equal to 3, the total number of inversion that we can get is 2. That is 3, 2 and 1. The total number of inversion is 3 and 2 is 1 pair and 2 and 1 is 1 pair. So total number is 2. So similarly, if we take the value of k and n, we need to take a minimum between k and n minus 1. So k can't be greater than n minus 1, because if an array contains n elements, the maximum number of inversion that we can get is just n minus 1. If k is greater than n minus 1, it doesn't make sense. So what we will be doing is, like, we will be limiting the value of k between k to n minus 1 only. So what we will be doing to get the exact k pairwise is, like, we will be summing up the entire n minus 1 till k minus 0 to k minus k till k. We will be summing up this entire thing to get the value of n to k. So for n to k, what we will be doing will be, we will be summing off the count of n minus 1 to k minus I, where I ranges from 0 to, that we see is minimum of n minus 1 to k minus I. So this is the logic. So let's see the code how it works. So the code is, let's see. So like I already mentioned, the base case is when n is equal to 0, the total number of arrangement is 0. When k is 0, we will return 1, because when k is equal to 0 means the array should be in an increasing order. So there will be only one arrangement which contains an array of increasing order. So here we are using an 2D array for memorization to reduce the time complexity. If the value is already calculated, that is if it is not minus 1, what we are doing, it is like we are returning the value that is already pre-computed value. And then we are having an variable known as int pair, which contains the sum of all the pair of n minus 1 elements with different number of remaining inverse pair. So what we are doing is like we are looping till the minimum of n minus 1 and k. We have seen this logic behind. So we are taking minimum because an array of n contains minimum of n minus 1 inverse pair, maximum of n minus 1 inverse pair. So we are taking minimum because the k value greater than n minus 1 does not make any sense. So we are taking minimum of n minus 1 to k. What we are finding in the loop is like we are calculating the sum of the value of n minus 1 to the value of remaining inverse pair k to get the total sum. We are adding it and we are placing it in an 2D array for to reduce the pre-computation task. So finally we will be returning this total number of arrangement we get from value of n and inversion pair k. So let's try to run this code. Wow. So if you guys any doubt, please put comment and follow for.